This episode is made possible by the generosity of our listeners. Thank you.
Welcome to the Creation Science
for Kids
show. Does science have anything to do with our attitude? Proverbs teaches us where our focus should be, how to look at life, and how to be ready to do some serious science. Then we look at some cool things stars are showing us that throw a wrench in stories about the past that leave God out. Plus, we get to hear about the coolest ice of all, glaciers. Praise the Lord. I will give thanks to the Lord with my whole heart, in the company of the upright, in the congregation. Great are the works of the Lord, studied by all who delight in them. Full of splendor and majesty is his work, and his righteousness endures forever. He has caused his wondrous works to be remembered. The Lord is gracious and merciful. Psalm 111, verses 1 through 4. This is episode 70 of the podcast where we learn about Jesus, our Creator, and his amazing world. Hi, I'm Sherry Fields, your host, and I'm joined today by my co-hosts, Timothy.
Hi.
And Joseph.
Hi.
To follow along with what we're looking at, check out the show notes. Creation Science, kids.com/glaciers. Oh, hey, be sure to listen to the end for the punny science joke of the day. So we're working our way through Proverbs 8 because there are some amazing things toward the end of the chapter that I just love about how God created. But we're starting much earlier in the chapter, and right now we're up to verses 13 and 14. Would you read them for us, please, Joseph?
The fear of the Lord is to hate evil, pride, and arrogancy, and the evil way, and the froward mouth do I hate. Counsel is mine, and sound wisdom. I am understanding, I have strength.
Thank you. Okay, so this is that first phrase, the fear of the Lord is to hate evil, is one of the most important definitions that the Bible gives us. If you look, particularly in the Old Testament, it often describes people who are following God as God-fearers, people who fear the Lord. So that can be kind of confusing to think about, can't it?
Yes.
Yeah, because you don't go around saying they fear their mom, they fear their dad, they fear their pastor. So we're not used to fearing the way the Bible talks about. So this verse tells us what it looks like to recognize how scary God is, but yet honor and worship him at the same time. It starts out, the fear of the Lord is to
hate evil.
Yeah. So hate. Now, I looked up most of these words. Hate is pretty basic. It means exactly the same thing in Hebrew as it does for us. It's a strong, negative, push away, I don't like it emotion. So we can all picture what that is like, right?
Yes.
Yeah. So that's how we are to feel about evil. Evil is anything that causes badness. It's a very basic word. It's actually only 2 letters when it's translated into English. It's very short, very small. It's very close to our word bad. So to have strong, bad, negative emotions towards anything bad, that's pretty straightforward. We can understand that. Then it says, gives us some examples of the kinds of evil in particular. And that's one of the lovely things about the Hebrew poetry is it tends to say something and then say it again and say it backwards. And you get a much better feel for whatever concept they're talking about, which I really appreciate. Okay, so the pride is interesting. It's only used here. It's not the usual word for pride. And it means to rise up too high. So that's kind of easy to think about in ourselves. What would it look like or sound like if somebody was doing this? Any ideas?
No.
We talk about somebody who's full of themselves, who thinks too much of themselves, to put yourself in a higher position than you can actually handle. That you're saying, I can do more, I understand more, I am more than you actually are. Does that make sense?
Yes.
It's pretty straightforward. Arrogancy, it's actually almost the identical word. It's only got a little bit of different sound. And it's for exaltation, majesty, pride. So it can be a good thing when a country is victorious. They are exalted. They have majesty. But this is talking about a person when they are feeling like that in themselves, that I have won. I am important. I am on top. Then we already had evil, but evil way. We've talked about this going through Proverbs before. Way is used throughout both the Old and New Testament rather a lot. First of all, what is a way in English? If we're thinking about a way, what will you picture?
It's a road.
Right. A road or a path. So, Joseph, do you remember what way means when they use it in the Bible?
Your lifestyle.
Yeah. And if you picture it, you think of, okay, if I'm going from here to there, I go along a path and it's taking me to a particular place. Because I chose that road and I am choosing to walk on it, I will get to that destination. And a lifestyle, even though we don't tend to think about it, what I choose to spend my time on, what I choose to make important in my life will take me to a destination. So in the Hebrew thinking, it's much clearer. It's easier for us to say, well, I got this lifestyle and it makes me happy today. They were very conscious of where it was going to take them. So the evil way is a lifestyle that is wrong in itself and it's going to a wrong end. It's got a bad goal. Okay, now we get to one of my favorite words in the King James is froward. Not because it's good, but just because it's interesting. What does froward mean?
Crooked.
In the Hebrew, it means to be changed or twisted. For you big people, perverted is very much what it means. It's taking what was originally straight and meant for one thing and twisting, bending it so it's no longer straight, it's no longer serving its original purpose. And what the fear of the Lord is hating is the froward mouth. So, what did God make our mouth to do besides eat?
To speak.
To speak what? What kinds of things does God like?
Nice stuff.
Helpful things, blessings. James talks about it straight out. Our mouths are to bless God, to bless other people, and yet we use it to curse people. What kind of way to live is that? That's an example of a froward mouth. God gave us mouths so we could share information and be a blessing to those around us, to express love and connection. And instead, people twist it and use their mouths to be cruel. All these things, it says, do I hate? That's continuing. If you remember, wisdom is the one talking. So she's the one saying, the fear of the Lord is to hate evil, and I hate these things too. Then wisdom continues on with counsel. Do you know what counsel means? Can you think of how? Yeah, today people go to counseling. Do you know why they do that?
To get advice?
Right. When people are hurting, when they don't know what to do, they'll go to somebody who should be wise and can give them advice. Try this, think that, look at it this way. And that is exactly what wisdom is saying. I am the one that can tell you this is the wise thing to do. This is what I suggest you do if you want to have a good result. Sound wisdom, the next one, counsel is mine and sound wisdom, is really interesting. It's to have substance. So it's real. It's not just an idea out there that you hope is true. It really is true. It's reliable. And it's also in one translation I looked at, this was translated as common sense. So wisdom will help you see things as they really are and say, well, of course it should be done this way. That's the way the world works. Have you ever put something down and then it fell on the floor or got damaged and you're like, what? How did that happen?
No.
I know it does to me. So it has to you. But one of the things I'll remind myself is that object that I was hoping would behave my way instead obeyed the laws of physics. It had no choice. It obeyed reality rather than what I wished it would. Sound wisdom is helping you get your thinking in alignment with reality. Isn't that cool?
Yes.
And we will see that more when we look at what the scientists are discovering about stars. Understanding. That's fairly straightforward. If you understand how 2 + 2 = 4, then you're likely to remember tomorrow how to do a problem like that again. It means to really get a concept, to have insight into why it's happening, what's going on. And then wisdom finishes up with, I have strength. Strength's fairly straightforward. If somebody says, I need you to pick up that box, and you have the strength, what will you be able to do?
Lift it.
Right. What do we call that in physics? We talked about it doesn't matter how much you push on something. If it's not actually moving, you don't have any
inertia.
Yeah, sort of force. It's not doing any work. So wisdom is what transfers, gives you the ability to not only want to do it and try to do it, but to actually accomplish it. To have power and might is another way of thinking about it. Is that something you want to have?
Yes.
Yeah. Nobody wants to try and say, well, I had really good intentions, but it just didn't work out. Wisdom will help us get beyond the, well, I'd really like to that actually being able to do it in a way that works. Okay. So I already mentioned sound wisdom and understanding are important for science. Can you see how all of these rejecting pride, thinking too much of myself, rejecting bad lifestyles, rejecting twisting what I say, and of course our words come from what we're thinking, and having advice and common sense and really understanding and having the power to actually do something would be useful if you're studying science. If you're a scientist, do you want these things?
Yes.
Absolutely. If you don't really understand what's going on, and if you think, well, it should just work my way because I think it, will you ever find the truth thinking that way?
No.
No. That, in fact, that is what allowed the scientific revolution to take place, is instead of saying, well, we can't do better than Aristotle. Aristotle had amazing thoughts, and the way he said the world works must be the way it works. Now, it wasn't exactly self-arrogance, but still, we know all there is to know arrogance. And instead, people started saying, hey, wait a minute, let's look at the real world. Let's actually do experiments. And they applied God's wisdom. And many of those men were very godly men who knew perfectly well that they were using God's wisdom and fear of the Lord. Okay, so now we're going to kind of apply this using an article I ran into. Earlier this week, I was able to attend a meeting where they had a lecture for just ordinary grown-ups who don't know much about science, talking about how you could get all the elements from stars without God making anything, how things could make themselves. So that got me thinking, what are the things that creationists are saying about this? Because, of course, we've got some great astrophysicists like Dr. Faulkner and Jason Lisle. They know perfectly well that the secular explanations, the ones that leave God out, don't work, and that when God says he did it, that's a perfectly legitimate scientific way of saying, well, we can't do it today. God did a miracle in the past, and now we're looking at the ongoing results of a miracle. So I did find an article by Brian Thomas, who works for the Institute for Creation Research. And back in December, he wrote about 3 discoveries that mystify astronomers. And that's the name of the article. I'll have a link to it in the show notes. And they were so interesting, I thought I would share them with you because you guys can understand what's going on here. Okay, so the first thing they discovered was another planet. You know how they're finding planets that don't go around our sun. Back when I was a girl, not that long ago, we guessed there were probably planets around other stars, but we'd had no way of scientifically proving that there were any. But then they started finding ways. Do you remember how they can tell planets going around a sun since planets don't glow?
No.
Okay, we look at the stars wobble. A planet has to be big enough to have a gravitational pull effect on its sun. So we started out finding huge planets like Jupiter size, and we've been working down to about Earth size ones. We can now, if a star is close enough to us, we can tell that there must be something regularly pulling on it. So they've discovered a new massive planet. So that'd be like a Jupiter size one. It's going around a small, faint star, and it's so close to it that its year is 2.6 Earth days.
Whoa.
Yeah, that's pretty crazy to think of. Round and round and round.
I'm gonna live there. I'm gonna live there.
Oh, very funny. I don't think that would work very well. It has the largest planet to companion star ratio so far discovered. So compared to its star, it is huge, way bigger. You know, the sun has 99% of all the mass in our solar system. It's not like that with this other star system. So there's somebody from the University of Warwick said, its existence challenges theories of planet formation, which state that a planet of this size could not be formed by such a small star. According to these theories, small stars can readily form rocky planets, Earth-sized ones or Mercury-sized ones, but do not gather enough material together to form Jupiter-sized planets. So then Brian Thomas says, one wonders if God, who actually formed all the planets, the stars didn't make them themselves, placed this one in space just to demonstrate what only he could do. Think that's possible? That God could say, you think you got it all figured out? Well, try this on. See what I did here.
Yes.
He certainly is. And also, he points out, no one has ever watched a star forming a planet. The whole idea comes from them needing to explain the universe without a creator. They don't want to see God. They've already decided, even if I go to church and I love Jesus, I will not consider him to be the source of the universe. I will only look at natural explanations for everything. That's where they have to believe things like that. Not because the universe is saying you need to. They just have decided they must. Now, the next thing is that astronomers have used the world's largest single-dish millimeter wavelength telescope. I'm not sure exactly what that is. Sounds like a cool telescope. To target a galaxy at one of the greatest apparent distances from Earth. Okay, greatest apparent distance. So a great distance is?
How far away?
Right, and apparent. To appear means to be
able to see.
Right. So apparent means it appears that way. We think it looks to us like it's one of the furthest away galaxies we've ever observed. Therefore, they conclude that because it looks like it's super far away, it must also be super
small.
No? Well, yeah, to us it looks small. Think about light takes time to get to us. So they think it's
older.
They think it's older, that we're seeing light from billions of years ago, not just billions of years away, light years away. Okay, so they're saying this galaxy should be one of the earliest ones. In fact, there's a quote saying that they think it's very close to being one of the first galaxies ever to form because of how distant it is from us. So they guess if galaxies form based on the Big Bang and all without God's intervention and on their own, that it should look like a brand new, just developing, or they call primitive galaxy, lacking structure and heavy elements that it shouldn't have been able to make. Like in that talk I went to listen to, that stars start out with a bunch of hydrogen, and then they make helium, and then they gradually work their way up to making things like iron, and it takes gazillions of years to finally get heavier elements. So that's what they were expecting. They were expecting it to look like a blob, not have a nice swirl like we know our own galaxy has and stuff. So that's what they thought they would see. And not having heavy elements, only having the hydrogen and some helium. Instead, study authors, quote, find that its gas and dust properties are similar to those measured for local, nearby, ultraluminous infrared galaxies. So, when they look at it, it does not look like a baby galaxy at all. In fact, this is happening so often as we're getting better and better telescopes to look at galaxies far away that it's the mature, distant galaxy problem that as they look far away, they expect things to be older, that we're looking further into the distant past. But they're finding more that look just like ones nearby. Now, we haven't discussed how we could see starlight from so far away in a while. Do you remember what God told us 10 times in the Old Testament that he did to the universe to get it so enormous? Okay, my favorite is where he talks about doing this like a curtain, that he stretched it out like you would a curtain or a tent. So if you think of a tent, it can be in a small bundle that you can pack in your car, or even some are small enough they'll have them in the back of their backpack. And when you get to your destination and you're ready to have some protection over you to keep the mosquitoes off and stuff at night, you put up tent pegs and you form it into this 3D shape that takes up a lot more room than it originally did. That's what God said he did to the universe. And the way, because it's done in Hebrew, we can't tell how much he did do in the past and how much he is still stretching out the heavens. But that things are far away, but still look very much like similar things. Who is going to say, well, yeah, and who's going to be surprised? Are we surprised that a galaxy far away from us looks similar to ones close?
No.
No, because we know, when did the nearby galaxies get made?
Right when our galaxy was made?
Right. Do you remember which day of creation week?
1.
No. Yeah, that's a good guess. No, actually, the light was first, but he didn't make the stars yet.
The 3rd.
Close. It was day 4. So, our galaxy was made on day 4. When was this far, far away galaxy made?
On day 4.
Day 4. So, this does not bother us at all. And then the last one that he points out is that they've been watching this interesting star exploding over and over again. We see stars. Do you know when they really explode enormously and send out huge amounts of material and light, what it's called? It's called a supernova. So this one has gone supernova over and over again for the last 50 years. When scientists are making up how they believe the universe works, they think supernovas should only be able to happen once, and then the star is all space dust. So the guy talking about it, the lead researcher, said, this supernova breaks everything we thought we knew about how they work. It's the biggest puzzle I've encountered in almost a decade of studying stellar explosions. So they're guessing that the star was so massive, had so much stuff in it, and was so hot that it could have generated enough antimatter in its core to explode and collapse over several decades. And another guy watching this star said, these explosions were only expected to be seen in the early universe and should be extinct today. This is like finding a dinosaur still alive today. Of course, there are creationists who are looking for dinosaurs alive today, but we're expecting this kind of thing to only be able to happen billions of years ago, and yet we're watching it happen. So God keeps putting things as scientists are carefully documenting what they actually observe, that if they stop and think about it, will help them realize that that pride and arrogancy that wisdom hates, when people start saying, my way of looking at the world is the only way, the best way, the way you all should, and if you don't, you're stupid and ignorant. Wisdom says, wait a minute. God's way is the best. He is the one who is exalted. Follow him. He will guide you, but don't put yourself above God. The universe is silently declaring God's glory every day, and it's cool to find out about things like this, isn't it?
Yes.
Okay, now it's time to hear from you. What do you have for us today, Timothy?
Glaciers.
All right.
Glaciers are ice that collected and packed together and melted and refrozen.
What else do glaciers need to do?
They need to be in motion. They need to move around.
Right. So they just dance left and right and do the hokey pokey?
No.
No. How do they move?
They slide, and they also go in water and float.
Right. So if you think about it, water is always trying to go which direction?
Down.
Down. Ice is water, and it's getting pulled by gravity down. So most glaciers are up high, like on mountains, and they are flowing down. So what kinds of glaciers are there?
There are small ones.
Where are those? The small ones would be
down where it's warm.
Not down, but yeah, so near the equator. But how would they still be there if they're where it's warm?
Be up high.
Yes. So mountain glaciers can be quite small. Where is the biggest one?
In Antarctica.
Right. Antarctica is covered with a giant glacier. What do we call such a huge one? There are two huge ones.
An ice sheet.
Right. So there's Antarctica. Where's the other great big ice sheet?
At the North Pole.
Almost. The North Pole isn't a glacier because it's not sliding over land. It's floating on the ocean. But here's the...
In Greenland.
Yeah. Greenland is a large island way up north, and it is covered by an ice sheet of glaciers. Okay. How did the ice get there in the first place? If it's way up high.
Snow collecting.
And then what happens to the snow? As you get more and more snow.
It packs together.
Right. It gets packed, and it can only form in conditions where it doesn't melt the next summer. Otherwise, we'd have a glacier on our roof.
Oh boy. It would flatten us.
Yeah. So it can sometimes feel like a tiny glacier or slide off like a glacier, but it's not called that scientifically. So you've got snow packed together, and at some point the snow gets squished so much, what happens? Snow is very light and fluffy with lots of air in between.
Oh, it cracks open.
It will, but it turns to...
Ice?
Yes. And then it's talking about the first, 140 feet? Here we go. So it takes 492 feet, 150 meters for the bottom layer of snow to be totally ice. And how thick does it have to be for the glacier to start sliding down the hill?
150 feet.
Which is?
46 meters.
Right. And then, did this one talk about how it'll crack at the top?
Yes.
Yeah, where is that? Okay. If you look at pictures of glaciers, and especially people who are climbing around glaciers, at the top it's full of these kinds of things. What is that?
A big crack that looks like a canyon that goes down forever.
Yeah, it's called a crevasse. They're very dangerous because it can have a layer of snow on top, and you won't even know you're stepping on it till you've fallen in. And they're very deep. That forms because as it's moving, the ice will split apart. It's brittle, but at the same depth of ice that will allow it to move, it'll become, what's that word? Flexible. So you think of like a sheet of plastic. You can bend it and it doesn't crack. And that's at 150 feet, 46 meters. So that's what allows the bottom of it to just slide along. The top keeps cracking back and forth as it flows over steeper parts and shallower parts and stuff. But the bottom is flowing along. Okay. What do glaciers do to the land around them as they're flowing downhill? What happens to their mountain?
They cut it like a knife.
Well, not exactly. It's like having a very powerful sandpaper shaper that's it's carving it. I used to live in Alaska, and it was full of U-shaped valleys. So it takes a rough mountain where it would have...
rocks.
Yeah, but rocks that would come down, like you look at the top of these mountains, and they're all rough, and it'll come to a point, and it's almost straight up and down. When a glacier flows through, it turns it into a U shape, a wide bottom, fairly steep sides, but also very smooth. It polishes the valleys. And do you remember, what is it? This used to be a glacier, but all the ice is melted. What has it left behind?
It's left behind a kind of rocky road.
Yes. So the glacier is constantly breaking off and carrying along everything from tiny particles of rock to huge boulders. And that gets any of them that are along the bottom will scrape along the ground. When the glacier gets to the end, it will drop, if it melts back for whatever reason, it will drop those rocks and leave them. You've got end moraines where the rocks at the furthest point the glacier went out, and you've got side moraines, and there's different names for the rock piles it'll leave behind. Drumlins are interesting because they're round hills that it leaves behind. Everything else around it was eroded away, but it's got this round cone-shaped hill, which is really cool. Okay, so we can tell, like where I lived in Alaska, there were some glaciers. There are fewer now than there were back then. We can tell there used to be a lot more glaciers on Earth. What do we believe caused those huge glaciers, and even like the ones in Antarctica, since it's a desert, but it's covered with all this snow? What happened in the past?
The Ice Age?
Right. Now, in your book, it said there have been bunches of ice ages, and the last one ended about 10,000 years ago. I did some study on that. First of all, when they're guessing about bunches of ice ages, they just guess. They have nothing they can look at in the rocks, because even the secular geologists will say, well, the newest ice age covered all the signs of the older ice ages and scraped them away. We can't tell that they're there anymore because the newest ice had taken away all the evidence of the old one. So we just believe in those older ice ages because we think that's how the world works. And the 10,000 years ago, what was actually around 10,000 years ago?
Nothing.
Just
God.
Right. So when they're saying 10,000 years ago, they are not saying it because of carbon dating or radiometric dating or anything scientific. It's just by looking at human remains and how all the scientific disciplines that study the past all work together and say, we think it was this long ago. We have decided. And the people who were first setting up that system knew very well they were going against what the Bible said, and they decided to stretch the time out so it would not fit the Bible. There is nothing that they can point to say, yep, this must be that old because of that. Now, they did find there was an addle stick, a throwing stick where you hold on to it and you throw the spear with it. And they found that it was coming out of a melting glacier in Colorado, I think. And it carbon dated pretty old. But we've talked about that too. Carbon dating for old things before like 700 BC start giving you too long ago ages because there seems to have been not as much carbon-14 in the air back then. So that's the only reason, but that's only a very small part of their reasoning. When they say this, they have just decided to say the last ice age ended 10,000 years ago and there were more ice ages. They can't even figure out how many ice ages they actually believe in. 5 is the most common. Others say more. A few say less. We think there was one. Now, do you know what would have caused the ice age? When was the world in a crazy time for the atmosphere and the climate?
The flood?
Yeah. Actually, for the ice age, it was after. Because if you had the floodwaters coming up, boiling out of the right down there next to the magma and lava and all, that was very hot water, and it would have melted into the ice. So we know the ice age was after the flood. But here's the thing. Okay, so Timothy, I know this is going to be half my report, but this is so cool. It's one of my favorite things to study. The secular people have to believe in an ice age. They see the signs of glaciers all over. But they can't explain how you could have it cool enough for the ice not to melt in the summer, but wet enough that lots and lots of snow was falling. Because if you get the world cool enough so that the snow doesn't melt, it slows down the whole snowfall production and you're stuck. You're stuck with very cold, dry conditions like we have in Antarctica today. When we look at the flood, we see two things. You had the fountains of the Great Deep, which were very hot, being closer to the center of the earth, and what else could it have been besides just water coming up out of the ground? And that we also see when we look at the world around us, we're much more active.
Lava.
Yeah, lava. And when volcanoes erupt, it's not just lava. They also send ash out into the atmosphere. 200 years ago, there started to be a series of explosions of volcanoes that sent out vast amounts of ash. There was a summer just over 200 years ago when all across Europe and North America, crops kept freezing. People froze or starved to death because they couldn't grow enough food. It was terrible. It was called the Little Ice Age. There was Mount Krakatoa was the most famous. That was a little later. But you had huge amounts of ash up in the air, blocking the sunlight, keeping the summers cold. And we could definitely see where that could have been happening during and just after the flood. Because right at the beginning of the flood, you would have had the rain washing the ash out. But towards the end, you didn't have the rain anymore. You could have had all these particles of dust floating in the air, keeping the air cool. But the oceans were also full of all that water from way down deep. ICR has done some computer models where they say water in the ocean could have been like 90 degrees Fahrenheit. So that's what, 32 degrees Celsius, somewhere right around there. It would have been bathtub water warmth. Water like that. What does it do all day long whenever the sun shines on it?
Rises.
Yeah. What do we call that? When water turns to steam or gas.
It evaporates.
Right. The water, like you think of your hot teacup, it's got water rising off of it all the time. It's not quite as much when the water is about body temperature or a little less, but there's still a lot. That's what causes the hurricanes in the summer, is all of that hot water rising off the ocean. That's something else ICR has done studies on, is these hyper hurricanes, they call them, which makes total sense to me. So you've got all this water rising into the air and getting out in the cold air so that a lot of it would fall as
Snow.
And you take that, lots of hot water, lots of cool air, lots and lots of snow, and lots of storms. And that's how you can explain like the ice cores that show different layers. They want to say each layer stands for a year. You could easily have dozens of storms a year. And you also look at where we know people lived right away. They lived much closer to the equator where they wouldn't have had all that ice to deal with. Not as much anyway. So you have a perfect mechanism started by the flood and continuing on for hundreds of years, we expect. Like Michael Ord is the most outspoken. He loves to talk about the Ice Age. He says he thinks it was probably all done where everything was getting to what we now call normal about 700 years after the flood. But you had huge amounts of snow forming enormous glaciers like we don't see anymore, covering all of Canada all the way down through down to the middle of Ohio in North America, covering huge areas in Europe that aren't covered now. There were some in South America that were a lot bigger than they are today, and covering Antarctica, because Antarctica right after the flood had forests. It was a comfortable place for trees to grow, and then they got buried in ice. Well, if you think about if they're growing near the ocean and the ocean is nice and warm, even though it's in the pole, it would not have gotten crazy cold like it is today until the ocean cooled down. And then they got buried, and ever since then, it's been a desert down there. And most of the snow that we see down there is really old snow from the Ice Age. So that's how you get glaciers. What else, when we look at a glacier today, what else is really cool about what they do or look like? How do they move? Because we talked about that they have to move.
They slide on the melting snow and ice.
Yeah.
They can travel up to 150 feet in a day. 46
meters in a day. Yeah. Did it talk about the slow ones? When you've got a cold glacier like in Antarctica, it can move just a few feet per year. But yeah, up to 150 feet a day. There was one time a glacier slid across an inlet of the ocean up in Alaska one day. So there was a pod of whales caught behind it They hadn't realized they were going to be stopped in there. And they were in trouble before the ice melted and they were able to escape. There was enough fresh water melting that it was harder for them to swim in because it's easier to float in salt water. And they were having a bit of trouble. They were worried about them, but the whales made it. But they were just taking a nap in an inlet, which was a good place to look for fish or whatever they wanted to eat. And they woke up the next morning and there was an ice wall blocking them in.
Oh, boy.
Yeah. So usually they don't move that fast. What about drinking the water, the melt water that flows out of a glacier? Is it very fun to drink glacier water straight out from the bottom of a glacier? No? Okay. So when I was in Alaska, we went up to a glacier and it was summer and we had on wading boots so we could walk in the stream flowing out from the bottom of the glacier. We didn't go back in the cave, but we did have a drink from it and it was terrible because there were all those teeny tiny bits of rock still in it that hadn't had time to settle down to the bottom. So we did not enjoy glacier water at all. So whenever I see bottled water that says glacier pure, it's like, are you kidding? Yuck. But if you had real glacier water straight out of it, what you would see in still bottled water that had been sitting around for a couple months is a layer of dusty stuff at the bottom. Did you see pictures of glaciers that used to be huge when they first had photographs and cameras and now are much smaller or are totally gone?
Yes.
Yeah. So that's something else. Like I mentioned, 200 years ago, we had a mini ice age. The glaciers were very large. And as we started exploring more of the north, or just glaciers that we knew, like in Europe, that the glaciers were doing fine. Now it's been a warming period. Things are better for crops. Things are safer for people, but they are not so great for glaciers. So a lot of people worry that if all the ice on Earth melts, that the sea levels will rise. Now, again, that's something else that happened before to us. During the Ice Age, huge amounts of the surface water were trapped on the ice sheets. In fact, we know that the sea levels were probably 200 to 300 feet, close to 100 meters, lower than they are today. We've found places where people had settlements or even cities and towns that are now buried under quite a lot of water. It's a pretty good guess that that's where stories of Atlantis being drowned. The first people always settled along water like they did right up to the time of the locomotive and the train tracks. Until then, you lived near water, and lots of people would settle around the oceans. So when the ocean rose 200 to 300 feet, your town was sunk, literally. So that's already happened. Of course, today there are a lot more people, so you've got millions of people rather than hundreds or thousands of people living right along the coast. So we worry about even it rising a foot or two. So far, that doesn't seem to be happening. If it does, it's just Earth still settling in and things not being stable because did God create the Earth to have ice ages and hot times and deserts? And
No.
God created the world
To be perfect.
perfect, to be a good place to live. But what happened?
Adam and Eve sinned.
Right. And then people became so wicked that God did what to the earth?
Made it flood.
Right. And ever since the flood, it's been a mess, both in geology and also here with our climate. And when Jesus comes back, lots of bad things are going to happen when he comes back, earthquakes and stuff. But then he will restore all things. And I hope he leaves a glacier or two for us to go visit, maybe go skiing on and have fun. But it's going to be a safe and comfortable place for us to live forever.
Yeah.
Don't forget, you can find links to all the things we've talked about today by visiting the show notes page, creationscience4kids.com/glaciers or /070 for episode 70.
Be sure to let your friends know about this podcast and ministry.
And to connect with all the rest of the things we do with the podcast, stop by the web address I got just for you, cs4ks, the initials of this show, .com, and find out how to send us your own recording. Write us an Apple Podcast review, drop us a note, become a monthly supporter, and see the heart of why this ministry is so important. Speaking of becoming a monthly supporter, running this podcast and ministry costs me money, and it takes a lot of time. We now have a Patreon account where you can help us out, like Pastor Brian Betworth and the Academy of Christian Apologetics for Moms. Thank you. If just a few of our listeners help, even with just $1 a month, it will help cover the rest of our basic expenses, and anything above that will help us improve things for the future. Visit cs4ks.com to find out how you can get involved. All right, I found a joke for us today. What do you call someone who steals a glacier?
I don't know.
An ice burglar. Like an iceberg that breaks off.
Oh. Well, this finishes up our show for today. Until next time, have fun treasuring our amazing universe and Creator.
Thou art worthy, O Lord, to receive glory and honor and power, for thou hast created all things, and for thy pleasure they are and were created. Revelation 4:11.